This video from GMATMathPro.com explores the basic hints and tactics you can use to attack data sufficiency problems. Specifically, we'll explore 4 tactics, and then at the end we will work through some actual GMAT data sufficiency questions and see how those tactics can be applied. If you're not already familiar with the basic format and structure of a GMAT data sufficiency question, you should probably go back and review that now before watching the video, because otherwise a lot of this stuff won't make any sense. So the first question we'll look at is, what does it mean to have sufficient data? The data provided are considered to be sufficient when it is possible to determine exactly one answer from the given information. On the other hand, the data provided are insufficient when more than one answer fits the given information. So here are a couple simple examples to illustrate that. In the first case, the data given are sufficient if we say, if x plus 2 equals 5, what is the value of x? Obviously, in this case, 3 is the only value that would satisfy this equation. There's no other value of x that's going to work. In this case, though, where we say if x plus y equals 5, what is the value of x? Now the data provided are insufficient to determine a unique value of x. Here, x could be 3 and y could be 2, or x could be 4 and y could be 1, x could be 5 and y could be 0. There's many different possible values for x, so here we would say the data are insufficient. And that leads into our first tactic, which deals with the case where you think the data provided are insufficient, but you're not sure, and you want to be sure. And in that case, what you want to do is find 2 different answers that fit the given information. For example, a room is filled with men and women. If 10% of the men in the room own cats, what percent of the people in the room are male cat owners? So you might look at this and say, okay, I don't think there's enough information because they never mention how many people are in the room, but maybe you've been burned by situations like this in the past and you want to be absolutely sure before you submit your answer. So all you have to do is find 2 different scenarios that fit the given information but give you different answers to the question. So for example, maybe there are 40 men in the room and 60 women. And if 10% of the men in the room own cats, that's 4 men who own cats out of 100 people. So 4% of the people in the room are male cat owners. Or it could be that there are 40 men and 10 women, in which case again we have 4 male cat owners, but now it's out of 50 people. So 4 out of 50 is 8%. So we have 2 different situations that fit the given, but that provide 2 different answers to the question. So we know for sure now that the data are insufficient to answer that question. The next hint is that you want to be aware of any assumptions that you're making as you solve a problem. And really you don't want to make any assumptions at all. You just want to take everything they give you at face value. Don't introduce any of your own information as you solve it. Now when I was a kid, I liked to take this philosophy to the extreme. For example, my dad would say something like, go outside and see if the newspaper's here yet. So I'd say fine, and I would go outside and walk to the end of the driveway. I would see the paper sitting there in the paper box, and I'd leave it there because he never said to bring it back. And I thought it was really funny. My dad never seemed to think it was that great of a joke, but what he may not have realized was that while this trait makes for an irritating, smart-alecky kid, it's also a trait that's critical to being a good mathematician. To do math well, you have to be extremely judicious about what information you apply to the problem you're trying to solve. You can't introduce extra things that aren't stated. So when you're taking the GMAT, you want to be in the mindset of that smart-alecky kid who doesn't do anything or doesn't take anything for granted except for what he's explicitly told. For example, this problem says if a times b equals 7 and a is not equal to 1, is a equal to 7? So I'm going to go through a faulty line of reasoning and see if you can catch what assumption I'm making. So if a times b equals 7, I know 7 is prime, and so the only way to get 7 is 1 times 7. So if a is not 1, then a must be 7. Because if it's not 1 times 7, it must be 7 times 1. Okay, so hopefully you caught the assumption that I made there was that a and b have to be integers. But that's never stated anywhere in the problem. So if they don't say a and b are integers, don't assume they're integers. So really, just because a is not 1 doesn't mean that a is 7, because now if a and b are not necessarily integers, it could be that a is 3.5 and b is 2. It could be that a is the square root of 7 and b is the square root of 7. There's a lot of ways for two numbers to multiply to 7 if you don't restrict it to the set of integers. Another example is here. So if x, y, and z are points on a line, and xy is equal to 10, and the length of yz is equal to 5, what is xz? So take a minute and draw that out. And if you just do it quickly, you might say, okay, well, if we know xy is 10 and yz is 5, that must mean that xz is 15. But the problem with that is that no one ever said that x, y, and z are in that order, that the points are in alphabetical order. It also could be arranged x, z, y, in which case xz would have a length of 5. So it's important that you think this way, like these little nitpicky things that maybe people would hate you for in real life. You have to think that way when you do these GMAT problems. The next hint is to simplify everything you can. In other words, if something is written in a way that is a grumpflu, the third hint is to simplify everything that you can. In other words, if you can rewrite something in an equivalent but simpler way, you should always do so to make things easier for yourself. For example, let's say that you were in a room full of people and you decide you're going to go to the grocery store. And before you go, you, just out of politeness, ask if anybody wants you to pick anything up. And so a guy comes over to you and he says, yeah, can you get me 1 banana, 4 bananas, 3 bananas, and 2 bananas, please. So you would probably just write down 10 bananas instead of 1 banana, 4 bananas, 2 bananas, and 3 bananas, right? There's not really any percentage in having to go through the grocery store thinking, okay, I've got to get this weirdo 1 banana, 4 bananas, 2 bananas, and 3 bananas. You just get him 10 bananas. A lot easier to think of it that way. And so on the GMAT, especially on these data sufficiency questions, they're going to be like that guy who asks for 1 bananas, 4 bananas, 2 bananas, and 3 bananas. They might give you something like, is 3x plus 2 greater than 2x plus 9? And it's up to you to be like, you know, come on, man. All you're really asking is x greater than 7? But it's going to be on you to rewrite it in a simpler form. Okay? The other example where it might come up is a word problem. In this word problem, you have the organizers of a charity basketball game sold 2 types of tickets to the event, youth and adult. If they sold 950 total tickets, how many youth tickets did they sell? So we've got like a whole paragraph of information here, and you want to distill it into a simple equation where you can kind of see what it's saying at a glance. So if you just let x be the number of youth tickets sold and y be the number of adult tickets sold, then you could write this equation. X plus y equals 950 because you know they sold a total of 950 tickets. And then you write x equals question mark to simplify the question. All we're looking for is x. You don't have to think about it in terms of how many youth tickets did they sell anymore. So always try to simplify everything that you can, whether it's the given information or if it's one of the 2 statements in the data sufficiency. And the last hint that we're going to cover in this video is solve only as far as you need to, but be careful. And what I mean by that is, since these are data sufficiency questions, we don't have to solve all the way to the end. We don't have to find out what x is or what y is. We just have to find out if the data is sufficient to find one unique value of x or y, or whatever we need to do to answer the question. So for example, if you are doing a problem and you get down to the point where you know that 243x is equal to 7,981, and the question is, what is x? Don't waste your time actually solving for x. Don't bother dividing 7,981 by 243. Okay? Obviously, it's going to work out to something, and it's only going to be that one answer, whatever it is. But we don't really need to know, and we don't really need to care what it is. So don't go any further than you need to. But I say be careful, because sometimes it looks like either there is enough information or there's not enough information at one point, but if you actually finish solving it out, you'll find out it's the opposite of what you think. One way I see it happen sometimes is if you have something like this, like a quadratic. 4x squared minus 3x plus 1 equals 3x squared minus 5x. And the question is, what is x? The trap here would just be if someone thought, okay, I know a quadratic equation generally has two different solutions, so there must not be enough information to find x in that case, because who knows which of the two solutions it would be. But if you simplify that to x squared plus 2x plus 1 equals 0 by bringing everything over to the left side and factor it and solve, you see x equals -1 is actually the only solution. So in that case, that is enough information, because this is one of those relatively rare cases where there's exactly one solution to a quadratic equation. So that's why I say be careful, and it's going to be kind of up to you to gauge how well you can trust yourself to skip steps at the end. But it's definitely going to be a time saver if you can get to the point where you know that the data is sufficient or insufficient without solving the problem to completion. Okay, so those are the 4 tactics. Now we're going to look at some actual GMAT data sufficiency problems and see how these 4 tactics can be applied.